Hi, I'm Alex. In marketing mix modeling, we often see sales fluctuate naturally over time, even when your media spend stays flat. Maybe baseline sales dip in the summer or spike in December. We call these time effects. In Meridian, we handle this mathematically. Let's say T is the total number of time periods in your data, say 104 weeks for a 2-year model. Ideally, we want to estimate a time effect mu for every single one of those time periods. However, estimating a unique parameter for every single week results in a large number of parameters and can be an inefficient use of the model's degrees of freedom. Meridian solves this using knots. Instead of estimating t parameters, we choose a number of knots k, where k is less than or equal to t. This is a form of dimensionality reduction. We estimate the values at the knots and interpolate everything in between. Let's look at the math of how we fill in the gaps. Imagine we have a knot at week 60 and week 80. We need to estimate the time effect for week 75. Since there's no knot there, the model looks at the neighboring knots and calculates a weighted average based on distance. The distance to the left knot is 15. The distance to the right knot is 5. The knot at week 80 is 3 times closer than the knot at week 60, and so it gets 3 times the weight in the weighted average. The time effect mu75 is then a weighted average of the neighboring knots at 60 and 80. If we repeated this exercise for each mu t between the two knots, each mu t would fall on a straight line between the two knots, demonstrating linear interpolation. When k equals 1, all time periods are measured with a single parameter. It acts as a common intercept for the entire duration of the model. When k equals t, the knot-based approach simplifies to using a dummy variable for each time period, also known as one-hot encoding. Now, the strategy for setting knots depends heavily on your data granularity. In a national model, you have limited data, only one observation per time period. Setting the number of knots close to t leads to many parameters with a limited amount of data. A low number of knots is often an efficient way to improve the sample size to parameter ratio. The default number of knots in a national model is 1. Geo models are different. Because you have many geos, each with data every week, you have a much higher sample size to parameter ratio. You can afford more knots, sometimes even a knot for every time period, which is the default in geo models. The knot-based approach is a powerful tool. It can capture arbitrarily complex trends and seasonality patterns, and even multiple seasonality patterns at once. It can capture these complex shapes with relatively few parameters. Let's look at these charts, which fit knots to simulated data. They show how a complex time series of 152 time points can be accurately explained by just 15 knots. Notice how the smoothed estimate in orange effectively captures the seasonality of the observed data in green. It does this without modeling a parameter for every single week. In practice, selecting the number of knots often requires trial and error. Wouldn't it be better if the data could just tell us how many knots it needs? This is why Meridian offers AKS, or automatic knot selection. AKS removes the guesswork, giving you a statistically rigorous starting point. Thank you for watching.